I am Ivan Michael Siachans of Batangas State University, Bachelor of Science Information Technology from Section IT 2102. And for today's video, I'll be giving my summary in Chapter 3, Network Protocols and Communications. So let's start. Introduction. More and more, it is networks that connects us. People communicate online from everywhere. Conversations in classrooms spill into instant messages. Chat sessions and online debates continue at school. New services are being developed daily to take advantage of the network. Within this chapter, you will learn about these models as well as the standards that make networks work and how communication occurs over a network. Communication fundamentals. A network can be as complex as devices connected across the internet or as simple as two computers directly connected to one another with a single cable, and anything in between. Networks can vary in size, shape, and function. However, simply having a wired or wireless physical connection between end devices is not enough to enable communication. For communication to occur, devices must know how to communicate. Communication begins with a message or information that must be sent with the source of destination. The sending of this message, whether by face-to-face communication or over a network, is governed by rules called protocols. These protocols are specific to the type of communication method occurring. In our day-to-day personal communication, the rules we are used to communicate over one medium, like a telephone call, are not necessarily the same as protocols for using another medium such as sending a letter. Rule establishment. Before communication with one another, individuals must establish rules and agreements to govern conversation. Protocols must account for the following requirements: an identified sender and receiver, common language and grammar, speed and timing of delivery, confirmation and acknowledgement requirements. Message encoding. Encoding also occurs in computer communication. Encoding between hosts must be appropriate format for the medium. Messages sent across the network are first converted into bits by sending a host. Each bit is encoded with a pattern of sounds, light waves, and electrical impulses depending on the network medium over which bits are transmitted. The destination host receives and decodes signals in order to interpret the message. Message formatting and encapsulation. When the message is sent to a source destination, it must be used in a specific format or structure. Message formats depend on the type of message and the channel that is used to deliver message. Letter writing is one of the most common forms of written human communication for centuries. The agreed format for personal letters has not changed. In many cultures, a personal message contains the following elements: an identifier of the recipient, a salutation or greeting, the message content, a closing phrase, an identifier of the sender. Message formatting and encapsulation. The format and contents of the frame are determined by the type of message being sent to the channel over which it is communicated. Messages that are correctly formatted are not successfully delivered or processed by the destination host. Message size. The size restrictions of frame require the source host to break a long message into the individual pieces that meet both minimum and maximum size requirements. The long message will be sent in separate frames, with each frame containing a piece of original message. Each frame will also have its own addressing information to the receiving host. The individual pieces message are reconstructed into original message. Message timing, the access method, determines when someone is able to send a message. Flow control. In network communication, source and destination hosts use flow control methods to negotiate correct timing for successful communication. Response timeout. Hosts on the network also have rules that specify how long to wait for responses and what action to take in a response timeout occurs. Message delivery option. A one-to-one delivery option is referred to as a unicast, meaning there is only a single destination for the message. When the host needs to send message using a one-to-many delivery option, it is referred to a multicast. Multicasting is a delivery of the same message to a group of host destinations simultaneously. If all hosts on the network need to receive the message at the same time, a broadcast may be used. Broadcasting represents one-to-all message delivery option. Rules that govern communication. One of the best ways to visualize how the protocols within a suite Interact is to view the interaction as a stack. Protocol stack shows how the enable protocols within a suite is implemented. The protocols are viewed in terms of layers with each other, level service depending on the functionality defined by the protocols shown in the lower levels. Network protocols. At the human level, some communication rules are formal and others are simply understood based on the custom and practice. For devices to successfully communicate, network protocol suite must describe precise requirements and interactions. Protocol interaction. HTTP is an application protocol that governs the way of a web server and a web client interact. TCP is a transport protocol that manages an individual conversations. IP is responsible for taking formatted segments from TCP. Ethernet is a network access protocol that describes two primary functions: communications over a data link and the physical transmission of data of the network media. Protocol suites and industry standards. A protocol suite is a set of protocols that work together to provide comprehensive network communication services. TCP or IP protocol suite is implemented as TCP/IP stack on both sending and receiving hosts to provide end-to-end delivery of applications over a network. Open standards. An open standard encourages interoperability, competition, and innovation. It also guarantees that no single company's product can monopolize the market or unfair advantage over its competition. A good example of this is when purchasing a wireless router from the home. There are many different choices available for a variety of vendors, all of which incorporate standard protocols such as IPv4, DHCP, 802.3 Ethernet, and 8.2.7. Internet standards. Internet Society, responsible for promoting the open development and evolution of Internet use throughout the world. Internet Architecture Board, responsible for the overall management and development of the Internet standards. Internet Engineering Task Force develops, updates, and maintains Internet and the TCP/IP technologies. Internet Standards. Internet Research Task Force (IRTF) focus on the long-term research related Internet and TCP/IP protocols such as Anti-Spam Research Group. Internet Corporation for Assigned Names and Numbers, based in the United States, coordinates IP address allocation, management of domain names, and assignment of other information use TCP/IP protocols. Internet Assigned Numbers Authority, responsible for overseeing managing IP address allocation, domain name management, and protocol identifiers for ICANN. Institute of Electrical and Electronics Engineers, organization of electrical engineers and electronics dedicated to advancing technological innovation, creating standards in a wide area of industries including power and energy, healthcare, telecommunications, and networking. Electronic Industries Alliance, best known for its standards related to electrical wiring connectors and the 19-inch racks used to mount networking equipments. Telecommunication Industry Association, responsible for developing communication standards in a variety of areas including radio equipment, cellular towers, voice-over devices, satellite communications, and more. International Telecommunications Union Telecommunications Standardization Sector, one of the largest and oldest company standard organizations that ITU defines standards for video compression. The benefits of using layered model, assisting in protocol design because protocols can operate in the specific layer have defined information for they act upon a defined interface for the layers above and below. OSI reference model. The OSI model provides an extensive list of functions and services that can occur at each layer. TCP/IP protocol model. The TCP/IP protocol model for Internet Network Communications was created in the early 1970s and is referred to as the Internet model. The data units as application is passed down to the protocol stack on its way and transmitted across the network media. Various protocol information is added at each level. This is known as encapsulation process. Encapsulation example, when sending message on a network, an encapsulation process works from top to bottom. At each layer, the upper layer information is considered data within the encapsulated protocol. For example, the TCP segment is considered data within the IP packet. Encapsulation, this process is referred to as shaving host and is known for the encapsulation. Encapsulation is the process used by receiving device to remove one or more protocol headers. Network addresses. Network layer source destination address responsible for the delivering IP packet and original source to the final destination. Data link layer source and destination addresses responsible for delivering a data link frame from one network interface card. IP packet contains two IP addresses. Source IP address, the IP address of the sending device. Destination IP address of the receiving device. Data link addresses. IP packet is encapsulated in data link frame and contains data link information. Source data link address, the physical address of the device NIC is sending the data link frame. Destination data link addresses, physical address of the NIC that is receiving the data link frame. Devices on the same network. Role of the network layer addresses. The network layer addresses or IP addresses indicate the original source and the final destination. An IP address contains two parts: network portion, the leftmost part, the address that indicates which network the IP address is a member. Host portion, the remaining part of the address that identifies a specific device on the network. Role of the network layer addresses. When the sender of the packet is on the network of the receiver, the source of the destination IP address will represent hosts of the different networks. Source IP address of the sending device, the client computer PC1, the destination address, the IP address of the receiving device, the web server. Role of the data link layers addresses, sends on the receiver of the host, the Ethernet data link frame cannot be sent directly to the destination host because the host is not directly reachable in the network of the sender. Source MAC address, the Ethernet MAC address of the sending device PC1, the MAC address of the interface. Destination MAC address when receiving device, the destination IP address is on a different network from sending device. So that's all for my summary of chapter 2, and thanks for watching.